the rays that come out from isotopes, from radioactive isotopes, to identify the leaks in oil or gas pipelines. Some oil or gas pipelines can be broken. They can have holes in it. These holes can form oil or gas out of the pipe. Okay, so we can identify the presence of holes inside these pipelines by using these rays. We can use an instrument called Geiger counter. We use an instrument called Geiger counter. We can pass, we can pass Geiger counter on the pipeline. When there is a leak or a break in the a broken part inside the pipeline, it will give a high reading. It will give a high reading. So we can know that there is a leak of the pipeline in the pipeline or in the oil or gas pipeline. Okay. So we have here three uses. Three uses. Of course, we have extra uses for isotopes, but here we have only three. Okay. So at first we studied isotopes. We said that isotopes are atoms of the same element. Atoms of the same element. So they are the same element. They are not different elements. They are the same element. They have the same atomic number but different mass number. The difference in the mass number is due to the difference in the number of nitrons. Is due to the difference in the number of nitrons. In each one, we have only one electron and one proton. One electron and one proton. Hydrogen, 1 is the only element without nitrons. Okay, it doesn't has nitrons. Okay, the second one has one electron, one proton, and one nitron. So it is different from hydrogen 1 in the number of nitrons. Hydrogen 1 has one electron, one proton, and two nitrons. So they have different mass number due to the difference in the number of nitrons. Okay. When I tell you give reason, give reasons, give reason. Isotopes have different mass number. Why? Ahmed
due to
Mustafa,
the different
Mustafa,
in number of nitrons.
stop, stop. Ah, Ahmed Mustafa, where are you, Ahmed?
Huh?
Ahmed.
يا مستر.
Isotopes have different mass number. Why?
Because they have different nitrogen.
Raise your voice, Ahmed.
Because they have different nitrogen.
They have different mass number. Why? Why, Ahmed? They have different mass number. Why?
Because they have different nitrogen.
Okay, because they have different number of nitrons. Okay, like we have also another example of isotopes, chlorine 1735 and chlorine 1737. We said that isotopes are radioactive. They are radioactive means they can emit radiation. They can emit rays like alpha, beta, gamma, X-rays, and so on. They can be useful or harmful. Harmful, they can cause diseases. And useful, by we can use them in medical use to kill cancer cells, to kill cancer tumors. Number two, to sterilize medical equipments to make them clean from bacteria. And the third one is in industry to identify the leak in gas oil pipelines. Okay, this is about isotopes. This is all about isotopes. Now let's move to just
Mr. Identify
The
the
use
leak
of
in air.
harmful
one student only. One student only.
Mr.
Just
The number three, to identify the leak in air في the
the leak
industrial
in
unit.
oil or gas pipelines. Leak means a broken one, a broken one. Leak or shortage. Disadvantage. Disadvantage.
Mr. The use of harmful isotopes are
What? Any? Ah,
uh uses of harmful isotopes here.
No, not harmful. We are talking about the uses of isotopes. When we talk about uses of isotopes, we talk about using them in useful fields. Okay, not in harmful fields. Now let's move to the second lesson, electronic structure. So we will talk here about electronic structure. Okay, we will talk about electronic structure. As we said in the last lesson, that any atom contains two numbers, atomic number and mass number. Atomic number is the lowest and the mass number is the largest. We said that atomic number is the number of electrons or protons. In this lesson, we will talk about the number of electrons, the atomic number. When we make electronic configuration, we will talk about electronic configuration. We will know how to distribute the electrons on the energy level. For example, we have here sodium Na. Sodium is 11. As I said, we will take only the atomic number. We will not take the mass number. We use only the atomic number because when we make electronic distribution or electronic structure, electronic configuration is the same. We make electronic configuration for the atomic number. So how can we distribute these electrons on the energy level? As we said before, that we can have from 1 to 7 energy levels. Any atom in the periodic table can have from 1 to 7 electrons. The lowest atom has only 1 level, and the largest atom has 7 levels. Okay. Right. What about sodium? To distribute these electrons on the energy level, the first energy level, we have a rule here. The first energy level takes 2 electrons. The second one carries 8. The third one 8, and so on. Okay. Right. How can we distribute the electrons of sodium? Sodium has 11 electrons. 11 electrons. So we put 2 electrons in the first energy level because the first energy level can carry only 2. And then we put 8 electrons in the second energy level. We still have only 1 electron because we have 11 electrons and we have only 1. The third energy level can carry 8, but we have only 1. So we put 1 in the third energy level. So the electronic configuration of sodium is 281. The first energy level carries 2, the second one carries 8, and the third one carries 1. Okay, is it clear? Huh? Is it clear?
Yes, yes.
Okay. This is called electronic configuration or electronic structure. So if I gave you some examples, some elements, some atoms, and I told you to write the electronic configuration, you will do like this. Okay. Right. Now let's move to talk about how to identify the position of the element in the periodic table. how can we identify the